Great. Cool. So, looks like I have a few folks this morning. Say hi in the chat if you're here. Um, so for a little context, a little catch up, I have been working on Project Euler, which is a math-based series of problems, and we've hit some size limitations on those based on, well, dataweave's just not optimized for that. And I was on a call doing my weekly game session with a couple of buddies last night who are also developers, and one of them's, I was asking if they had ideas for other language agnostic code quiz sites, and they suggested the a couple of options. One is the Cryptopals crypto challenges, and I got to looking at those a little bit, and I think those are, while also not ideal for dataweave, something we can definitely make some headway on. So, yeah, so I think we're going to start that. So today we're going to start with a new project. So let's see, is it Command Shift P? Yes. We're going to create a new library project. Org.avio consulting. And we're going to call these Cryptopals challenges. And sure, and Crypto Pals challenges. And I don't want to dash there. Okay. And for those who are new, we are using the Visual Studio Code development environment for dataweave. Dataweave is a transformation language originally developed for MuleSoft, and it's embedded with the MuleSoft runtime. If you So MuleSoft is an integration tool, but we are also going to. It can also be used in a number of other scenarios, including like Apex, if you're a Salesforce person. And in this case, it's also now its own available library for you can just write transformations and things with it. So it is a DSL. It's not a full language, but you can get quite a bit done in it. And we are going to try to solve what code quizzes we can with it today. And mostly it's, so I've learned a lot in the last week of basically like how dataweave optimizes um, when it's iterating and that kind of stuff, you, what kinds of things are more performant than others. So we can take advantage of that today solving some of these problems. So file, open folder. Let's see, did we, I guess it did not create the project, did it? So let's try that one more time. Create project, dataweave, create new library project, org.avio consulting. We'll say Cryptopals challenges 1.0, Cryptopals challenges. And no, that's the issue. We want Cryptopals challenges. There we go. We probably borked up our Project Euler. Do you want to open in a new window? No, I don't want to open it in a new window. I want to open it in this window. Okay, so here is our scaffolding for our project. So we have DWL with a sample module and a test suite for that sample module. And we're going to delete both of these because we don't need them. And we're going to start our own fresh module. So let's look at our Cryptopals challenges and go through them. So what is Cryptopals? It is to teach you about some basic cryptography stuff, strengths and weaknesses of different cryptographic systems and algorithms. It is very, as I understand it, it's very similar to taking a cryptography class, but you're learning it with code. So they have 8 sets of challenges that get progressively harder. So we're going to start with the easiest ones. We'll probably never get to the end, but that's okay. And where do you start? You know, it says right here, start here. So, and then these are the folks that created it. So we're going to do that. We're going to start here. Crypto challenge set 1. They said this is relatively easy, but you don't skip them. And it has 8 problems. So we're going to convert hex to base64, which I know for a fact is something that we can do in dataweave with just built-in like libraries in dataweave, though I think we're probably not going to use those because if you look at fixed X or here, we're going to need to be able to iterate through our binary, and that could get a little hinky. So in dataweave, we'll probably manually do the conversions ourselves instead of using the language. So to do that, we would have to write a function that converts hex to binary, and then another conversion that converts binary to base64. Okay. So yeah, so let's start with problem number 1. So it just says here, convert hex to base64. So for those of you who aren't familiar with what these mean, so hex to hex specification, hexadecimal. Here we go. Math and computing, it's a base64 or simply hex numerical system. So binary is, 2, base 2. Hex is base 16. We're used to working with base 10. So basically it's going to have 0 through 9 and for the first 10 digits, just like our decimal system. And then it's going to add on a few letters after that to represent up through 16. So 0 to 9 is numbers, and then they have A through F to represent 10 to 15, right? Our number system, you just tack a 0 on the end at 10. Their number system has more numbers, so we use letters to represent that. Okay, so as you can see here, we have this string which has numbers and A through F letters in it. It's a hex string, and we need to produce a base64. So we can look at what base64 means real quick. Base64 specification. Base64, binary to text encoding schemes that represent binary data. 24 bits can be represented by 4 base64 digits. And so we have a conversion table here. So if the binary character is this, then the base64 character is this. And it goes, let's see what we got here. Yeah, it goes all the way to here. And then they have, you use padding on the end because, well, your length of your characters may be different than your, yeah, anyway, we can get to that when we get to that. So if we wanted to do this in just using the out-of-the-box dataweave, it would look something like this. Well, let's do that first. So we have this string, and we wanted to produce this output. So dataweave, let's create a new module. We're going to call this module let's call this let's do this the same as they do in the dataweave reference. Let's name it. So in dataweave reference, that module would be the binaries, right? From base64, from hex to base64 to x. Exactly. We're going to implement those functions. So we're going to call this our binaries module. So new module binaries, all right? And we'll say from hex. So we need a from hex. And that is going to take a data is going to be a binary. Or no. Data is going to be a hex decimal string. So we'll just call it string here, right? And we're going to return a binary. So we could do this just as, so if we used the out-of-the-box stuff from dataweave, we could just do this. We could go import from hex from DW core binaries. And we'll just do DW core binaries from hex data, right? We don't even need that then. That way we won't even import it. So if we did that, that would get us from hex to binary, right? And then what's our challenge say? We need to convert that to a base64. So on to base64. Actually, let's just write this. Well, this is actually hard to test this. Hex. Let's do this. From hex to base64. Let's do that. So if we do from hex to base64, then it's a lot cleaner. We can just do this. Then binary DW core binaries to base64 binary, right? What is it not like here? Expecting type binary but got string. Ooh, interesting. If I do as binary here, right? As binary, does that work? No. Okay, so we may have to, I mean, I know for a fact we can do something like this, where we do import star from DW core strings, right? Or binaries. Binaries. And we could just do this. From hex data, map this, do to base64. It still doesn't like that. Expecting binary but got string. Oh, right, of course. This should be string. Right. Okay, so we had it right the first time. It was an issue with our function because I changed what it was doing. So this needs to be string now. So this is right. Okay. So if we did that, that should work, right? That's going to convert it from hex to binary. We don't even need the as binary right here, right? Because it's just going to be binary. And then convert that to base64. So I think this should work fine. But I don't think it's what we're going to want in the long run. But we're going to try it. So from hex to base64 described by it should convert a hex string to base base64 in do. So if we give it this input, right? Must, let's make this on a new line, must equal to, and then let's give it this output. Let's see if this test passes. It should pass, right? However, save, oh, cancel, save, run our test. So then the problem becomes if we want to act on the binary between, right? Which we almost certainly do. So we're going to need a function that converts hex to binary and lets us do something with that binary. So we may actually need a lookup table. But that test passed. So so I think this isn't going to work for our next step though. So, because I sort of cheated and looked ahead a little bit last night just to make sure that it's going to do what we need. So if I do fixed XOR, so for those who don't know, an XOR algorithm is taking binary and taking binary string, or binary, yeah, taking binary and another binary, and using the second binary as a secret, you compare all of the bytes in the string to, or all of the bytes on the statement to create a new binary statement. And then you can then on the other side of that, if somebody else has the exact same secret, they can convert it back. So let's look at, saw a good XOR algorithm. Yeah, XOR cipher. Here we go. Yeah, so here's an implementation of it. So here is the string that they're encrypting, right? And this is their secret, and they're using the same secret on each chunk of it. And so if these are different, then it's 1. If they're the same and it's 0, different, 1, same, 0, same, 0. And so what you get at the end is another binary. And then you can use exactly the same secret in the other direction to convert it back once you get it on the other side. And if we look at their, so you feed it the string, you hex decode it, and then XOR against it, and it should produce another hex statement. So, which means we need to act on each binary in each 0 or 1 in the binary and encode that and then convert that back to hex. So this probably isn't going to give us what we want. We actually need to create a table that generates the binaries and does then we can write functions to iterate through those. And so, which makes me think we need to rewrite this. So we're going to do this with a lookup table. So, and we're going to write this as separate. We're going to create a from hex to base64, from base64 to hex. We'll go in both directions. So we'll create like from hex to binary, from hex or from base64 to binary, and etc. So let's write that. So this is actually going to stay the same, the test, but we need new tests. So from hex to binary described by, it should convert a hex string to binary in do. hex to binary. So let's get an example of what that's going to look like. I may have to go here. So hex. We have a binary conversion table in here. We'll just Google one. Hex to binary table. There we go. Okay, so decimal 0, hex is 0, binary is this, and it goes up to F, and it goes to 10. I think all we need is for our table is up to F, which is what they're doing here. So let's do that. We're going to create a table from this. Yeah, so from hex to binary. So if we say one, two, three, four, and do is going to be, oh wait, no, we have undo, must equal to, right? Must equal to, then it would be 0001, 0010. Let's make it an array of binary elements, right? 0001. That'll be easier to work with later. We can always join it if we need to. 0010, 0011, and 010. Okay. So from hex to binary, right? And if we give it 1, 2, 3, 4, let's even, it's fine. We can just pass it the string and then return an array. All right, so we'll do that. So we'll leave this alone for now. Function from hex to binary is going to take a data of a string and return an array of strings, right? So we'll say data split by $sign, right? Let's go look at that. Dataweave strings. I think it's actually in core, if I remember right. Is even log lower. It's going to be in alphabetical order. So I want the S's. Scan all matches found. Split by into a, yeah, so we'll just tell it to split by that, right? Split by every item. And if we actually run this, we should get a failing test with 1, 2, 3, 4 as an array, right? Which is what we want right now. And then we'll have to create a conversion table. Yep. Expecting root to be 001, but was 3. Expecting root to be 001, but was 1. Expecting 0011, but was expecting root to be 0, 0, 1, but was 1, expecting root to be 0, 0, 1, 1, but was 3. Right. Okay. Yeah, that's right. Okay. So we've got our, let's save this as a variable. Do, dun, 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 do var characters equals this. And then characters map character, and then we need a function here for that. That's going to be something like look up binary character, right? And then we need to look up binary functions. So it's going to be a character, it's a string, and it's going to return string, and it's going to be just an object, right? So create this object, hex to binary table is going to be, so if we have, so B1 is going to be 0, 0, 0, 0, and then 2 is going to be 0, 0, 0, 1, and we'll just build the table, right? 3 is going to be 0, 1, 0. 1, 5, 0, 1, 0, 0. 6 is going to be 0, 1, 1, 0. 7 B 0, 1, 1, 1. 1000. 9 is 1001. 10 is, oh no, 10 won't be that. Am I doing this? No, that's right. So it'd be A, right? A is going to be 1010. B will be, so we'll need to uppercase this character just in case, right? Uppercase our character. So we have B is 1011. Let's put commas at the end of these. C B 1100. D it's 101. Oops. E B. So, oh, we forgot 0. This is actually wrong. I'm off by 1 here. So 1. Yeah, we'll fix that in a minute. 1, 1, 1, 0. is going to be 1. Okay, I need to take a break for a few minutes, so I will be right back. I'm just going to step away for just a few minutes. I'll be right back. All right, sorry about that. So we have our numbering off here. So this is 0. This is 1. 2 should be 10. 3 should be 11. 4 should be 100. 5 should be... Okay, yeah, that's where I messed up. That's where I got off. Okay, so we'll do this. 5 should be 0, 1, 0, 1. Right? Yeah. 6 is fine. 7 is wrong. 8 is, or 7's fine. 8's fine. 9 is fine. A, B, C, D, E, and F. Okay, so that's our table. We need to make this a variable. Yep. And we do X to binary table character, right? That should give us back our map, right? Why doesn't it like this? Invalid field. All right, let's make it 0. That should work. And then we'll do that, that to make my OCD happy. Okay, so now if we run this, what do we get? This ought to work, right? Yay. Okay, so we have a hex to binary conversion table. That works fine. So now we need a from binary to base64, and we should probably go in the other direction as well. So we're going to do a from, let's do from base64 to binary, described by this, right? It should convert a base64 string to binary and do from base64 to binary, and we'll do, let's get a table for base64. So base64 characters, we care about capital and lowercase. Yeah. Okay. We're going to have a padding we're going to have to care about as well. Well, we'll figure it out. So we'll do hello. All right. Hello. Must equal to array 0, 0, 0, 1, 1, 1. E lowercase e is 0, 1, 1, 1, 1, 0. 2 L's is going to be 0, 0, 1, 0, 1. 0, 0, 1, 0, 1. And O is 1, 0, 1, 0, 1, 0, 0, 0. Okay, so let's do that conversion table. So define our function from base64 to binary data. It's going to be a string. We're going to return an array of string equal, all right, do our characters equal data split by that, and characters map character lookup binary upper. Oh no, we're not uppering this time. Character, right? Because we do care about upper and lowercase characters this time. And does this do the whole alphabet? Is there a what is the, let's look up a better table. Let's see. Base64 to binary table. It's the same table we were just looking at. So Okay. Nope. There we go. So these are the numbers. Yeah, I think we could just use the Wikipedia one. We're just gonna have to write a bigger thing here. So how's that gonna work with our, so these are different length. We'll have to figure it out. We may have to do some padding. Okay. Up base 64 to binary. So over to binary character string equals do, right? Var base 64 to binary table equals. Is there an easy way to just grab this table and chunk it in here? Oh yeah, we got this. So if I grab this, tab over, perfect. So do that. Actually, we're going to take the index off. So we don't want the index, right? We just want the binaries. So what did I do wrong there? Okay, so the character, so the index is 0, character is A. Actually need to switch the order on that. Let's just write it out. A, it's gonna be 6. B is gonna be 2, 3, 4, 5, 6. C is gonna be 3, 4, 5, 6. So, do we have the numbers on here? Just the letters. Yeah, there's the numbers. Okay. Yeah. So we have every letter through Z and 1 through 9, or 0 through 9, and plus and forward slash. Okay. So we're at 45 minutes. I will continue working on this after the hour. B, C, D, E, and we'll pick up where we left off tomorrow. 0, 1, 0, 0, F. So the question becomes, what are we going to do about, so these hex binaries are 4 digits with leading pad 0. So F is going to be, one. So it's different encoding for sure, because it's 0, 1, 10. So it's the, instead of doing numbers and then letters, it's letters and it's the full alphabet and numbers, and because we have 64 characters, right? So that makes sense because it's base 64. So we've got 64 characters. Yep, starting with 0 and going to 63, and then if we have any extras, we pad it with this, right? Okay, that makes sense. But that means the binary, how are we going to handle? I don't know, we'll figure it out. New to all this, you guys, if you can't tell. So 0, 0, 0, 1, 0, 1. F, G is going to be 0, 0, 0, 1, 0. H is going to be, I is going to be 0, 1, 0, 0, 0. J is going to be 0, 0, 1, 0, 0, 1, right? Yep. K is going to be 0, 0, 1, 0, 1, 0. L B 0, 0, 1, 0, 1, 1. M, and keep following the same pattern. So 0, 0, 1, oops, 0, 0, 1, 1, 0, 0. And we'll follow that same pattern. So 0, 0, 1, 1, 0, 1. Next one will be a bunch of ones. MNO 0, 1, 1, 1, 0, right? Yep. And then the next one will have all of the ones. P 1, 1, 1, 1. We'll start over here now. E Q gonna be 0, 1, 0, 0, 1, 0, 0, 0, 0. Q R Mm, 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 mm. Nope. Mm. Hey guys, I can count binary. 1, be 1, 0, 0, 0. Z. Hey, we're through capital letters. 0, 1, 1, 0, 0, 1. A gonna be 0, 1, 1, 0, 1, 0, right? Yep. B 1, 0, 1, 1. Okay, so I'll finish this and we'll pick up where we left off tomorrow. Hopefully tomorrow will be more entertaining than just watching me write tables. We can actually start implementing the algorithms. So, all right, I will see folks tomorrow. Have a good one.